So far, in our electricity unit, we've come across all of these variables. And in some instances, we've seen that some variables show up in more than one equation. Okay, we've got 2 more equations to go over. So you are going to learn of 1 more variable. We're only going to add 1 more variable to this list. Now that we understand how to figure out, or we understand the relationship between electrical charge and energy and potential difference, current intensity, resistance, all of these things, when we're talking about appliances or we're talking about anything electrical, okay, what happens when I flick the lights and nothing happens? What do we often say? What's gone out? The power's gone out. Well, wait a minute. We haven't started talking about power yet. Okay, when we refer to power as the electricity that comes into our homes. Okay, last weekend, the power went out at my house during that, windstorm or whatever. So all of my electrical appliances shut off because there was no power coming into the house. We've got to figure out what power means. Electrical power is the amount of work that an electrical device can perform every second. Now, wait a minute. There's 2 new variables there. Electrical power is the amount of work done by a machine every second. Yikes. There's 2 words there that are new, and I said there would only be 1. But here's the thing. If we look at this formula, okay, so electrical power, PE is electrical power, is equal to the work done in the change in time, or in the amount of time. But here's the deal. If we look at the units of work, work is measured in what? Joules. What else is measured in joules? Energy. So here's the deal. Look at what we're going to do. We're going to make life nice and easy. We're going to get rid of this W, and we are going to replace it with E, because it means the same thing in this case. So this is the slight change from your textbook. Okay? Your textbook uses the electrical power formula as being PE is equal to W over T. W is work in joules. Well, we're already measuring energy in joules, and work is the amount of energy that something takes to accomplish a task. So let's make life nice and easy. Let's stick with a letter that we've already seen. Okay, so the formula for electrical power, all right, electrical power is equal to the amount of energy in the device every second. Okay? Now, power is measured in watts. So here's that last new variable to add to this list. Power is going to be PE with a small little e for electrical power, and it's going to be measured in watts. Okay, and I'm going to repeat that. We can look at the amount of energy an object uses in a certain set of time to determine the amount of power that it's taking. But here's the cool thing about electrical power, is it can also be represented by its relationship with potential difference and current intensity. So what I mean by that is that you can also calculate in watts the amount of power that a device has if you know its current intensity and its potential difference. So this comes back to what I've been trying to say, that there is, with the exception of resistance and time, every other one of these variables has more than one way to solve for it. That is the brilliant part of these equations, is that there's always more than one way. And your mind might automatically see something one way and figure it out using that, whereas somebody else might figure it out a different way, and neither of you is wrong. You're both right. Okay, that's one of the good things about all these variables. We're starting to see how they interact with one another. And they interact with one another a lot. Okay? When we do circuit labs, and we're going to be starting to do circuit labs next week, when we do these circuit labs, we can measure things like current intensity and potential difference. And we can calculate the resistance of something. We can also calculate the power that that thing is using. Okay, there's a lot of stuff we can do here. All right? So knowing these different equations now, and let's have a look at these equations. Okay, we are now, what is that first equation we learned? We learned the current intensity equation. So, I is equal to the charge of the object over time. What's the next equation that we learned? Potential difference. V is equal to what? E over Q. Right? What's the next equation we learned? Ohm's law. Ohm's law is V equals IR. Okay, and now we've also added two new equations to this mix. So both dealing with power. The first one is the electrical power of a device, and that is the amount of energy that the device consumes within a certain amount of time. And then finally, looking at the amount of electrical power that any device consumes is also looking at the relationship between the current intensity and the potential difference going through that device. So seeing all of these equations right here in front of you, okay? If I have to solve for I, what do I have at my disposal? Let's look at this. What do I have?
I equals Q over delta T.
I have I equals Q over delta T. Okay, if I want to solve for I, I've got I equals Q over delta T. What else do I have?
V equals IR, or IR.
V equals IR, resistance. What else do I have?
PE equals IV.
PE equals IV. Absolutely. Now, if I want to solve for Q, for charge, what do I have? What are my options?
I equals Q over delta T.
I equals Q over delta T and
P equals E over Q.
V equals E over Q. Okay? If I want to solve for V, what do I got? A lot. What do I have?
V equals E over Q.
V equals E over Q.
And V equals I over, or I times R.
V equals IR. And what's the last one? PE equals IV. Okay, so that's a total of 3, correct? 3 equations. For Q, how many do I have? 2 equations. For I, how many do I have?
3.
Oof, look at that. Now, let's look at the letter E. I've got two equations for E. What are they? Give me one.
V equals to E over Q.
V equals E over Q. What else? PE equals E over delta T, right here. So that's two options. Okay? What else do I have here? I have two options to solve time. However, actually, you know what? Yeah, we'll go for it. Sure, why not? Okay, let me find another color here. All right, let's go with delta T. What are my options for delta T? Jess.
I equals to Q over delta T.
I equals Q over delta T, and PE equals E over delta T. And let's not forget, last one, what are my options for PE? PE equals E over delta T. And PE equals IV. So the only equation, there's only one that you only have one shot at. Resistance can only be calculated using Ohm's law. Okay, that's the only variable here. And I repeat, that is the only variable here. Okay, that does not have any other equation to solve for it. Do you see this? So it is very likely that you will see problems where you've got to find one thing and then plug that one thing into another equation to find your final answer. Okay? We will practice those. But do these equations, does this make a little bit of sense to you? Do you kind of get an idea of this? Yes? Do we start to see how different things they use the relationship between current intensity, potential difference, energy, charge, all of these things, okay, play into the world of circuitry and play into the world of electricity. Do we see that?